everyone. I'm just getting a few things started here. Let's do a quick check on levels. How's the music? Actually, I don't have my headphones today because I find it really hard to talk over music. So, you all can enjoy the music, but I actually, I struggle with it. It sounds like a different mic. How about now? Streamlabs? What? Okay, is it fixed now? I swear. Every week it's something, am I right? There's no music for you. Let me turn it up just a little bit. I think it was just changing songs. So I've got the levels here. Looks like there's music. But you know. Also, check this out. I didn't think about this before starting stream. My cup with my drink today is green. Is it too quiet? Because I can turn it up. I never know how loud people want music in streams, because to me, having somebody talk over music stresses me out. So, all right, it's fine now. Good. Sweet. All right. I'm so excited. Math Monday returns. Couple of announcements. It looks like I've gotten permission or approval or whatever from Microsoft to do 3 streams in May. So I'm working on kind of scoping out a cool project, figuring out what we're gonna do and whatnot. So if you are of the machine learning interested type, get excited. Those will be on Sundays. But before I get too much further, hi to Maddie Two Shoes and Main Village. Hi, Eric. Ban Loki, 5-Shot, Third Tier, of course. Kenpafu, Dunstable Ramsey, Raphael Ruffles Dev, Porridge Irene, Sweeku. Have I missed anyone? Lord Azazel. Hi to everyone. The mother of algebra. I could fine. I guess I could go with that title if I have to. I'm doing kind of like the creepy thing and looking quite a bit at my my list of people to see if my mom shows up. Oh, thank you, Ian Alex Hart. 2 dog treats. Okay, it's been a while since I've seen you, so I don't have like my little notepad where I usually write dog treats on. I'll just keep a tally. Hold on one sec. Math Monday. And I'll just erase this maybe before I put this on online. Current dog treat count 2. Sweet. Doop doop doop. No one sees that. All right. Goodness. I know. I like our little small community. It's so nice, and I love seeing like a lot of the same people in the productivity streams and then the gaming streams. I don't know. It's nice. It's nice that you all feel like you want to spend time with me and hang out. And also like do math and stuff. All right, we're on that. My phone is not muted. Ooh. Rookie mistake. All right. How was everyone's Monday? I'll be honest with you. I was so tired today. I even went to bed early. I'll have you know, I didn't stay up super late playing video games, even though I really, really wanted to. I went to bed at like, I don't remember, but it was earlier than I normally do. And I just was like, all day long, my body and brain have been like, more sleep. When do we go back to bed? Like, can it be now? So I've had a very slow, meeting-filled, sleepy Monday. I filed my taxes though, so I feel very proud of myself. That's done. That's always something I loathe doing, so glad that's done. And as usual, I am excited for Math Monday, but we're going to kind of give people about half an hour to, you know, get comfortable. It's probably the end of the day for a lot of you, so get a snack, get a beverage. If it's late at night, like for Maddie Two Shoes, maybe get a fancy beverage. Get comfortable. Maybe go to bed. Yeah, okay, Maddie. Maybe go to bed. But get comfortable. If you like taking notes, make sure that you have your favorite notebook, pencil, etc., and that you are comfy. You got to be, at least for me, if I'm going to be learning, I have to be really comfortable. So that's why today I have my favorite Miyazaki sweatshirt. I have sweatpants. I am like super cozy. So get cozy, get excited for math. I don't have my math socks though. I'll be real. And then we'll get started. So tonight we're going to be talking about a couple of different things. We're going to talk briefly about exponents and talk about why we have certain rules for exponents and where that comes from. And then once we feel like we've got our exponent rules down, we're going to start talking about some cool things, monomials and polynomials in algebra. And this is some of my favorite stuff in algebra. I'm really excited to kind of do it all together because, I don't know, I feel like this is where the fun parts of algebra start. So operations with exponents, exactly, Lord Azazel. I also feel like, and you all tell me, but all the gold! Thank you so much! Of course, I will answer any of your career questions anytime, but thank you so much for using your Prime subscription. 3 months! Woo! Thank you. But I think I want like a topic overlay, maybe like in this scene, so that like I can kind of just have the topics for what today's stream are going to be, and then I can like point to them. I don't know. I feel like that might help some people when they want to know what we're going to be doing tonight, but I have yet to implement that. However, those of you who liked the programmable LEDs that I had on stream previously, guess what's back? Finally got the warranty fulfilled by the company. So I've yet to set them up, but be on the lookout for those because those will be in co-working streams now. So you'll be able to change the lights and everything and have fun with those during co-working streams. Yay! So programmable LEDs are back soon. I mean, they're right there in a box, but I need to actually set them up. All right. What is the math command that you are trying to use, Loafbone? I told you. Are you trying to do the colors? They're not up yet. They're still in their box. Oh, you're just trolling. Okay. Well, let me get a few things. Meowdy Pertner. What a good name. What a punerific name. Thank you so much for following. Welcome to Math Monday. So I'm going to switch here to our whiteboard, and I'm just going to write out what we're going to be talking about today. I'm also keeping track of our current dog treats so that when, inevitably we all have fun with Tennessee and Hubble later, we can give them treats. Oh, good night, Lord Azazel. Have a good night. Okay, so let's see. Previously on Math Monday, we have talked about a couple of different things. Caption problems. Hold on. Let me test. Ooh. Is it stuck on Prime subscription? Hold on, give me a sec. Let's fix this. Testing. Server. Hello. Hold, please. Why are you being a butt? Test now? Nope. Is the server down? Let me close this and... Testing? No, I think the server might be down. Shoot. Oh, nope. There we go. Possibly back? You might need to refresh. Is it back? Fingers crossed. And Sugar Britches, thank you so much for following as well. Can anyone verify for me that the captions are back and working, please? Come on. I think Yeah, I mean, so the server shows that it's outputting where it wasn't before. So fingers and toes all crossed. You might need to refresh. That is going to be, my hope is that a refresh still. Ah, jeez. Oh, like I did before. Yes, I can. Give me 1 second, please. And I will get the captions up. Oh, wait, Sugar Britches sees the captions. It might take a second. Does anyone else see the caption? You can mess with the font, Sugar Britches. You should be able to like change the font, move it around, disable it if you don't want it. But is anyone else okay, people are seeing the captions. Okay, good. All right. Whew. Might take a second. I'm sorry about the delay. Twitch third-party captioning is always a bit of an adventure, unfortunately. Boozy Raccoon, what a great name. Thank you so much for following. So, to review, previously on Math Monday, we have talked about equations. Specifically, last time we talked about systems of linear equations. Can anyone break this down for me? What does this mean? How did we solve them? What was involved here? What did we do? And then I have my sneaky water that ooh, I love it so much. I think I'm gonna make my stream cup always green now. And let's see, all the gold. Have you gone much into identity philosophy and math axioms in an earlier episode? We haven't talked about, I would say, identity philosophy. We have talked about identity properties previously. But we haven't covered too much of that yet. But you know, maybe in the future. And yes, how do we find solutions, Porridge Irene? You say we learned how to find solutions to systems of equations. How did we do that? And yes, using more than one equation to find unknown values. That math teacher, yay! Thank you so much. Yes, Porridge Irene. Okay, perfect. So you mentioned substitution. That was one of the ways we could do it. Absolutely. And good. Thank you for the shout out. Thank you for doing that third tier. If you want more math content on More Than Just Monday, please check out that math teacher. Her streams are wonderful. I mean, I've caught a few like lesson planning streams, but there's also been like tutorials, and seriously, check it out. Write it down. She's got some cooler stuff going on there. I feel like, do you have like worksheets? Oh, that's awesome. Right. That's so cool. I love your interface and your setup. And yes, Porridge Irene, you are 100% right. We also have the elimination method as well. And yeah, Ban Loki, you say subtraction. So that's the elimination method. So this is where we're using like, you can use multiplication, but where you're using like addition and subtraction, where you're actually adding and subtracting the equations themselves to solve the system of linear equations. But there's one more way. One more. And I'm glad you like linear equations, Proper Copper. I like them too. I like equations in general. I feel like that covers it covers like a lot of my bases in math. So what is graphing? Yes, okay, poor Irene, you're just like on fire today. Graphing. And when we graph, where's the solution? What is the solution when we graph our linear equations? Euler support group. That makes it sound like Euler's a bad thing. And yes, you got it, Porridge Irene. The solution when we're graphing our systems of linear equations is the intersection. And really quick, what is linear equation? Give me this in like plain speak, in like an easy, I'm telling you, you could tell me this in one word. What is just our common sense understanding? What is a linear equation? Any see if the captions will still work if I'm able to go back to my notes. We'll see. We'll see if it still allows me to do this. A line! Yes, thank you, third tier. So whenever you see linear equation, just think a line, right? And so when we have systems of linear equations, we're talking about more than one line. And if we put more than one line on a graph, the place where they intersect is the solution. So here's maybe a kind of like a little bit of a logical step forward from that. What might, graphically, what might a case be where we have no solution, where we can't solve it? Given that we are now thinking about our lines. No intersection, right, Porridge Irene. And when do lines not intersect? Hi, Divine Dev Studios, welcome. So what do we call it when lines don't intersect? Parallel, yes, Trupp and Panda, and Porridge Irene, thank you. So no solution would be if we have parallel lines. And I know that, oh no, that's not running into my head. There we go, all right. So that's a lot of what we've done so far. So tonight, here's what we're going to be talking about. We're going to be talking about exponents and some of their rules. Then we're going to talk about monomials and polynomials, polynoms. Pet the Mat, thank you so much for following. Welcome to Math Monday. And exponents and rules, monomials and polynomials, and if we have time, we often don't because we like to get off on tangents, we'll start talking about factoring. Okay. Okie dokie. All right, so that is what we're talking about today. So if we are going to start out here with exponents. Third tier gaming, you say Jess and that math teacher collab one? Whenever, that would be awesome. That would be a really fun stream. Okay, so somebody remind me, what are exponents? What are we talking about when we talk about exponents? Just like the end of the Monday. Like, oh, okay, the day is done. It's time for math. Yes, okay, so in terms of orthography or in terms of writing, we write them as superscripts, key turns right. So that might be something like x to the 4. Let me actually write this in a different color. 4 here is the exponent. And x is what we would call the base. So later when we're talking about, bases and exponents, the base is the number on the bottom, the exponent is the superscript. You're absolutely right. Or power, sometimes that math teacher's right, sometimes you'll hear this, talked about like a number raised to a power. That power, it's just another word for exponent. So in all the golds, you say multiplication of itself on itself. Loafbone says power, a number is raised to. And yes, Tramsy, thank you. You're getting at where I wanted to go with this, which is how many times to multiply a number by itself. Remember that exponents, it's not like some kind of unique magical thing. It's just a shorthand that we use. It's shorthand for, as Tramsy has told us, repeated. I'm not gonna run into my face here. All right, we're good. Repeated multiplication of the same thing. Number, variable, whatever. So What that means is that something like x to the fourth, right, is we're just multiplying x times x 4 times. So if I use that same example as up here, x to the fourth is going to be equal, we write 4 x's, and we just multiply them. So we've got 1, 2, 3, 4 x's, hence x to the fourth, or x, where our exponent is 4. All right, so like I said, though, remember this could also be said to be x raised to the power of 4 or x raised to the fourth power. It's all talking about the same thing. We're talking about exponents. Okay, so, and I guess especially since we have a lot of folks who aren't native English speakers, there are a couple of special names that we have. So x to the power of 2, we call this x squared. And similarly, x to the power of 3, we call this x cubed. Okay, and so if you hear us talking about squared and cubed, that's what we're talking about. Boa Morte, thank you so much for following. Welcome to Math Monday. Okay, so now, just like with pretty much everything we've learned about math so far, we have some rules for exponents. But just like with order of operations, I absolutely do not want you to just memorize it and think this is just the way it is just because. I would instead like you to learn why something is the case. And if you have tricks to memorize it after that, that's totally fine. But let's first try to understand why something is the case. So we're going to learn 2 rules about exponents tonight. Rules of exponents, rules about exponents, rules of maybe. Rules of exponents. The genitive case. All right. So, is there a term to denote when a number is raised to the number's value itself? A to A, 5 to 5, or 10. Oh. Deaf Hacker might know, actually. I will be honest with you all. One of the things that I've struggled with the most when teaching math has been like the fancy names for things. Because at least for me, that is the last thing I remember is like what the special term for something is. I'll know how to use it. I'll know all the rules. I'll know how to math it, right? But if something has a special name, I won't always remember what it is. But that's a great question. I'm hoping somebody in chat might know the answer. Okay, so rules of exponents. So does somebody want to give me maybe what they think the first rule is? Bless my dear. Brackets, porridge Irene. It's probably brackets. But if you would like, I think somebody should probably clip me ranting about order of operations and just make this a video that I can link to. Love Bud, I'm looking at you. Or third tier, my wonderful mods. So that I can always have that to link for folks to kind of be like, hey, here's the breakdown. Here's the dirty truth about order of operations. Limpid Kazanix, thank you so much for following. But yeah, porridge Irene. So I believe that the B in that particular mnemonic refers to brackets, which is kind of confusing because brackets are often used outside of parentheses, so it should be BPEMDAS, which again, things start to get more and more confusing because it's broken and it's a lie. But in any case, rules of exponents. Does somebody want to let me know a rule about exponents that they know? And we'll break down the why. I'll show you exactly why these things work the way they do. PEMDAS is a lie. Exactly. It's like my version of the cake is a lie, but it's PEMDAS, which somehow I don't think would be, as viral or like, yeah, I don't think that would be as popular, but it should be. It's the real lie. But all right. So I think the first rule of exponents I would want to talk about with you has to do with when we multiply two bases that are each raised to an exponent. The same base, but maybe different exponents, okay? So let's say we've got x to the 4th times x to the 5th. So first let's talk what is the rule, and then we'll talk about why. What is the rule when we multiply, bases that are the same? And, well, here's also a dirty little secret, is that every number is actually raised to an exponent. But how do we simplify this? Oh, and I think, Ed Stroyer, you are talking about logarithms. So we're not quite there yet. We are going to start with our basic rules of exponents, but we will get to logarithms. So don't you worry. Probably not tonight, but we will. Hi, Dominic Evans. Yes, give Dominic Evans a shout out. How is your research project going? I'm sorry I haven't been able to tune in lately. Ooh, yes. I haven't played Overwatch in years. That looks like so much fun. Also, the best freaking name ever. Oh, I love Overwatch. It looks wonderful. Also, I haven't played in so long, I probably don't even know what to do anymore. Yeah, because you were focusing on this media research project, right? How has that been going? Yes, okay, Trep and Panda. Exactly. So you remind us that the rule here is we add the exponents. Main Village, you might like Overwatch. Okay. But let's talk about why this is, okay? And DRKBX, I would encourage you to go, well, first of all, thank you for following, but I would encourage you to go back to some of the earlier videos where I break down, it's not necessarily that PEMDAS is a lie 100%, it's that it's very misleading and it's taught poorly. And I've talked about this on multiple different streams about why it's problematic, why it's misleading, and how to kind of think about it instead. So I would encourage you to go back to those streams. I think Third Tier might have just linked a video. But right now we are starting with algebra. So we started at the very, very beginning. We've had a couple months of Math Monday now. And we are going from algebra all the way, to infinity and beyond, depending on how long people want to stick around with me. So I will teach math for as long as people show up, but I wanted to start with algebra. So we are still making our way through algebra, but it's about going through all kind of aspects of math, even ones I'm bad at, like geometry. And I think the challenge really is that, and the reason, if I can give a justification for why I decided to start with algebra, it's that this is at least in my experience teaching math for many years, this is where the most amount of students drop out, or they start to struggle, or they start to just memorize, and they don't actually understand. This is where people start to hate math. A lot of times they start to hate it before, but this is where the anxiety really starts to kick in. And so I wanted to start with algebra because that will ensure that when we get to, multivariable calculus, I can trust all of you to have algebra skills because you'll have been here. You'll have been here with me from the start. And if you haven't, there will be all the videos on YouTube for you to be able to catch up. So we will teach as much math, or I will teach as much math. We as a community will learn together as much math as people are interested in. So there you go. All right. Okie dokie. So yes, and I saw multiple people explaining this, including Def Hacker. Thank you. But so we know the rule, right? And I feel like so much of math is taught of, here's the rule. When you multiply bases that are the same, you add the exponents. Why? Why do we add the exponents though? So in this case, let's think about what's actually going on here. Remember that what our exponents represent, right, is that shorthand for multiply this thing by itself this many times, right? So if we're to do this, let's break it down. So there's what x to the fourth is, right? And then we have this multiplication, and then we have x to the fifth, right? And x to the fifth is just that. But look at what we have here. Knowing all that we know about exponents, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're saying multiply the same base times itself this many times and this many times, which gives us x to the ninth. And so that's why the rule is to add it, because you have to remember that exponents are just a shorthand. It's like a nice way so that our wrists don't fall off and we don't have to like write 4 x's every single time. I mean, when you get into like some really complicated physics or, you know, a lot of you loved Friday night when we were talking about supermassive black holes. Well, when we're talking about things that are a billion times, you know, something raised to 9 or 10, nobody wants to sit there and write that thing out 10 times, 15 times. Nobody wants to do that. So we use exponents as a way to make it a lot easier to talk about that iterative multiplication. And that's why this rule works, is because of that shorthand. That really all we're doing is we're combining two same base, right? And different numbers. And that is why we add them. And so you can remember when I multiply, you know, bases that are the same, I add my exponents, but I do want you to understand why. So a couple other things to show you real quick is that I think a lot of people here kind of intuitively understand, we've already been through this, that x times x is x squared. But if it helps, also remember that we have a 1 there. We don't always write the 1, of course, because again, we love our shorthand. We love things to be easy, but the 1 is there. A simple x on its own, a 4, a 5, all of that, those are all raised to the 1 power, the first power. And so when we multiply it by itself, we add our 1s and we get 2. And yes, key turn is also absolutely right. We're going to see equations and you know, functions in math where we might actually have a variable in the exponent. So we might have something that looks kind of like this. And don't worry if this makes you panic. We're not there yet, so don't worry. But I do want you to kind of see what this might look like. So we might have y to the x times, actually let me use some different colors so it's a little bit clearer. Y to the x times y to the 3x. All right, what would this be? What would this be? And Stroyer, yeah, I mean, I've tutored all levels of math pretty much, from elementary school through graduate math. It was mentally exhausting, but it was so rewarding. And I would say that the students who came across clueless a lot of times had been taught very poorly, and all it took was just a little bit of extra time or patience or a slightly different way of approaching it with them. And at least to me, kind of the reward of seeing students who previously struggled, who felt lost, who felt that they are so aware when they're clueless a lot of times. They are, and there's like this self-conscious, like, it's very sad because nobody wants to feel like they don't know what they should know. It can make you feel like, you know, you don't have a lot of confidence, and it can be very exhausting and anxiety-inducing. And so, at least for me, the way that I see it is that, yes, helping those students takes more of my energy, but I also know that no matter how much of my energy it takes to help them, it's so much more exhausting and anxiety inducing and hurtful for that student to keep thinking that they're just bad at math and something's wrong with them. So at least for me, it's always worth the extra effort because I get to take a student who thinks that they're the problem and I get to show them that they're not, there's nothing wrong with them, they're not the problem, and that they can do this just as well as someone else. So, all right. And so yes, I've seen multiple people answering this correctly. So I'll just break it down a little bit slower. So be y to the 4x. And so we're gonna, as our algebra gets more complicated, as our math gets more complicated, we might see really funky stuff in the exponents. So it's good to remember not only what our rules are, but why we use those rules. So that later on, if you're panicking, you can think back to exponents are just a shorthand for multiplication. So if you do panic, you can just write it out and kind of figure it out that way. And Bono Kazooie, you say, you used to be intimidated by polynomials, now you love them. Yes! Polynomials are wonderful. And they explain, like, I don't know. Polynomials they can be very intimidating, but I think it's kind of like with physics where, at least for me, I struggled when the physics was very simplified, when constantly the physics problems were telling me to ignore this thing or ignore this other thing or just assume the thing is a sphere. And something always nagged at my brain. I was like, but that makes this all seem fake, right? It just seems like I'm estimating everything. And how do I do this for real? And so at least for me, I loved polynomials because their complexity reflected the complexity that exists in the real world, right? And math is the language that we use to describe the real world. And so I loved when the polynomials got really funky and got really complex because real life processes are complex. And so the polynomials were just kind of reflecting the complexity that already existed, in nature. So I always thought that was cool. But, oh my goodness, see, Ed Stroyer, it's stuff like that, exactly. Like, I love the story that you just said. For YouTube people, I'll read it out, but you say, I had a middle-aged lady that just wanted to learn how to calculate tips on her bills. So I taught her percentages based on 10% increments. She felt much more comfortable going out with her friends at that point. Yeah, like, the confidence that people get when they start to be able to do math, because I can't tell you, I think the most common thing I hear is, I'm just bad at math. Math just isn't for me. And it kind of breaks my heart because, folks start out and there's a lot of anxiety around it and kind of like shame even, and people feeling very sad about their inability to do math. And then they kind of like lean into it and almost own it as like an identity, as I think a way to cope. But just the joy and the confidence that you can give people by just helping them understand that math isn't this arbitrary, alien, strange thing. It's actually like your brain is hardwired for it. Like, it's very intuitive if it's taught right. And I don't know, I've had so many students go from failing math and telling me, I'm just not a math person. Maybe they won't ever love math the way I do, but at least at the very end, almost all of my students got to the point where they went, at least, I know I can do this. And I know that, I might not like math, I might not want to study it or something, but I know that I can do it well. And to me, at least, that's a huge, huge win. And summer deception. Of course. So, well, not to self-promote, of course, but I'm going through all of math on my channel. So if you want to catch up on the beginnings of algebra, it is on YouTube. A lot of people recommend Khan Academy. Yeah, okay, I see that math teacher recommending it. It's great. There's a lot of good videos there as well, but don't feel bad if it doesn't work for you. Okay? So one of the things I want to caution is that, like, people need sometimes different approaches when it comes to learning something. Everybody knows what works, like, well, hopefully you eventually should learn what works for your brain. So, like, I know that watching videos for me doesn't work for my brain. So I know that if I were to use something like Khan Academy, and I've tried in the past, with my ADHD, it doesn't work for me. I don't like it. But There are lots and lots of resources out there based on what kind of approach you need the most. I would say the big things are to really take your time. Remember that, like, if you're learning this on your own, there's no need for you to like meet some deadline. You're not you're not trying to, pass a test. Nobody's going to quiz you. So take your time and find the parts of math that really are interesting to you and focus most on understanding, not on memorizing. So whatever, if there's something you don't understand, don't just skim past it and memorize how to do it and move on. Go find more resources and listen, read, watch whatever resources there are until you feel like you understand it. Because I think one of the hardest things is that the pacing of modern education teaches you that it's okay to just kind of memorize and regurgitate on the test because, like, you're just trying to be good at it, right? If you're doing it for yourself, it can be really hard to unlearn that pacing and to learn that instead you're here because you want to understand it. So don't rush yourself. Don't feel like you're more or less worthy because you take it at a certain pace. And, just baby steps, especially in math, baby steps, because the future stuff always builds on the things you learn in the past. So if you put the work in now to kind of have that good foundation, future you learning more difficult math will thank you. I know, Keyturn, right? All of math, exactly. Well, we'll see how long people stick around with me. So, but nevertheless. All right, so this is our first rule of exponents, that when we multiply the same base, we add our exponents. And it's okay to remember the rule, but hopefully you understand why that rule is the case. Now, actually, let me number these. The second rule. Yeah, of course, Summer Deception, and welcome. Hopefully you find, the resources here helpful as well. I found that one of the things that I really love about streaming math is that I can take it at the pace I want to take it at, which is really nice because then almost no one, I feel like, has had the educational experience where the class runs at the pace that they need. And at least here, like, I'll answer questions as long as I need to. Like, we don't have to, there's no test I'm trying to give you. There's no deadline. There's no there's no homework right now. There's been some demand for it, but I'm planning for a cross-world move, cross-global, international move, and so I don't think I have the spare time right now to come up with homework problems and be able to grade them for people, but maybe in the future. Maybe in the future. And Cobbs, you ask about streaming calculus. So I will stream calculus. I'll say that sometimes where needed, I've taught certain proofs or certain theorems in calculus when we've needed it for the machine learning streams on Sunday. But Math Mondays are a start from the beginning and work our way to the top kind of thing. So currently in algebra, and we'll just keep going. So we will get to calculus. I will have to at some point, of course, teach geometry, which I am horrendous at. So that will be an adventure. That one that will be a trial, and that's okay. You all will get to see me struggle, which hopefully will help all of you. But it'll be whiskery, and after calculus comes calculus, the study of the calculus on the spherical cow. Exactly. I want calculus and a spherical cow on a t-shirt. I feel like that would be a really cute math t-shirt. Like maybe the calculus for the volume of a sphere, but it's a cow. Okay, maybe I'll talk to some of my artist friends about doing that. But I know, Lizard, and you've asked me a million times, so I think here's kind of the way that I'm looking at that. Because you mentioned the sum notation stream, so that would definitely be part of the how to read a scientific paper and how to break down equations stream. The way that I have tackled it so far is that, at least in May, the rest of the Sundays in May are the sponsored Azure streams. which I also need to do because of the aforementioned international move. Like I need the sponsorship money, sorry. And Math Mondays I've kept to our pace of algebra. So I think if anything was going to be one of those streams, it would have to be Sunday. And so it'll have to be post move, unfortunately. And all the gold, yes. Can I jump into linear algebra without reviewing integration? There's definitely parts of linear algebra that I feel like don't need calculus per se. I feel like you could do some of the fundamentals, absolutely. So if for you don't really want to review integration, I think you could go and learn some linear algebra and go as far as you can. And once you hit that integration, you just pause and you review. Like, who says that you have to learn it in like chunks o math, like in the right order? Especially if you have done math before and it's more of a review, I think you can kind of dip in and out as you need to. Okay. So, let's see. And Glowfly, yes! Learning math is fun, and calculus is my favorite, so I really can't wait till we get there. I mean, differential equations are my favorite, but like, calculus is the point for me where I really fell in love with math, and I thought that it was so beautiful. So, all right. It's Dreyer, it depends. Like, I actually have lots of folks that I've worked with, especially in machine learning, that found linear algebra way easier than integration. So I think it's definitely like a personal preference thing. Chunks o math, exactly, Bengismo. All right. Oh, and we got a Swedish redemption. Okay, let me get through the exponents. Let me get through the rest of the exponent rules, all right? And I will do a little Duolingo lesson and review my Swedish. Okay, so the last thing that we need to learn, actually before, whoop, haha, there are no errors because I can just move things around. One thing to remember here, before we move on to our next rule, is that I have reiterated this a couple of times now, but now I want to like sear it into your brain, is that this rule about adding the exponents and everything, that applies with one strong caveat, which is when the base is the same. So if we have, tablet, there we go. If we have this, okay, then we don't add all these exponents up together. That wouldn't make sense, right? So you handle your bases kind of like, if you want to rewrite it even, you can rewrite it like this, if that helps you see kind of what you need to do. It doesn't matter. Whichever way you want to group them, totally up to you. But you only add those exponents when the bases are the same. So we're going to bring our x's together, right? So we're going to have x. Oh no, I want that to be green. We're going to have x. And then 3 plus 4 times y. And then our y here is 2 plus 1. And that's going to give us x to the 7th, y to the 3rd. It's a little bit of a weird 7, whatever. So that is just a caveat that I want to give you all. And yes, I will, Deaf Hacker. I will practice my Svenska, I promise. I just want to get through this last rule so that it's a good break, especially when I'm thinking about the YouTube video. Okay. So lastly, and I think I saw somebody else say, "Oh my goodness, like there's so many rules for exponents," like Glowfly, right? Don't worry, we're only covering 2 today. Okay, so we're going to talk about what do you do when you multiply the same base but different exponents, and then we're going to talk about what happens when you take a term that has an exponent and then you raise that whole term to an exponent. So in that case, Gave it away a little bit, right? If we have this, remember, exponents are just a reminder to do something iteratively, right? So if we were to break down what's happening here, we've got two levels of iterative multiplication, right? And you can actually, a lot of people will be like, work from the outside in. You can do it either way. For me, it makes sense to start with the outside one, but I can actually show you both ways if people really, really want to see the other way. So in this case, what this 4 is telling us is multiply everything in that parentheses by itself 4 times. So let's do it. So then we have this, right? And we know, okay, that, right? And so the rule ends up being that you multiply your exponents. But those of you who've been around and you know my feelings on order of operations, remember that multiplication is also a shorthand. Our multiplication is a shorthand for iterative addition, right? So in this case, our 2 times 4 is just shorthand for this right here. Because we already know, we know why when we multiply bases that are the same, we add our exponents. We've solved, like we've got that down. We showed ourselves that that's the truth. And then here, all we're learning is that when we have this repeated, when we have the same addition repeated, we can also use the shorthand of multiplication to make our lives a whole lot easier. So that leads to the rule that I mentioned, that when you raise a term with an exponent to a power, you multiply. Similarly, I noticed this was helpful for folks before, if we have this, remember our hidden first power here, right? So this is just Is that going to go into my head? That is. Hold on. Shwoop. There we go. And so similarly, whenever we raise anything to a power, we're making use of this as well. This iterative addition is just multiplication. And so that's all. This power, this rule follows directly from the one that we just learned. Oh, porridge, Irene. Well, thankfully there will be VODs and everything will be on YouTube. So don't worry if you're not able to watch after the move and the time change. I will still put everything up on YouTube. So hopefully you can still kind of tune in. And Ed Stroyer, yeah. So I think the problem is that, we're kind of telling students, hey, this has always existed, but we never told you about it. And that's hard, right? Because just like with learning everything, sometimes you have to hand wave and you have to explain things conceptually, and then you introduce more complicated topics later. And I think, at least for me, I found that explaining that so much of math that confuses people is about shorthand, about abbreviations, that helped at least the students that I was teaching understand why sometimes we omit things. It's not just because it's arbitrary. It's because we, just like when we speak whatever language we're speaking, we truncate things, we smush things together, we have abbreviations, we have slang. It's for ease of use, and math is no different. So, hi Geeky Girl Sarah, and I'm glad Glowfly, I'm glad that the exponents being in different colors helps. If anyone is colorblind and would like to recommend like certain colors specifically for me to use, just let me know. But I try to use my colors judiciously to highlight things and make it a bit easier to follow. And yes, thank you for shouting out Geeky Girl Sarah. I think I missed your last stream, but what have you been working on lately? While doing this, I'm gonna pull up but there's a question, so I'll wait. And yeah, Vagozino, you got it. I will go over that. Absolutely. And Calvo, thank you so much for following. So the coefficients, it's not so much that they're hidden as that if the coefficient isn't explicitly given, everything is, well, actually, let me back that up. So this kind of gets back to something that we've talked about on previous streams called the identity property of multiplication. Oh my gosh, I hate property names. And I think it's stupid how we teach these. Identity just means you get the same thing back. Multiplication means we're multiplying. So if I tell you 4 times something equals 4, hopefully lots of you already know what goes here, right? 4 times something equals 4, well, 4 times 1 equals 4. And so what we're kind of showing with this hidden exponent is that it's essentially, it's just one of it. We aren't multiplying multiple x's by itself. There's just one, or if you'd prefer to think about it, you can also think about it kind of like that. That we're not doing anything extra to this. This 1 just represents that there's only one x there. Whereas when we have something like x squared, that represents that we are multiplying two x's, not 1. But the thing is that unless we explicitly have that exponent there, it's gonna be 1. So can you imagine trying to have a really complicated equation where everything is linear, so everything is just to the first power? But how awful would it be if we had I'm gonna give you an example, all right? I don't even know if this is actually something that you can solve, okay? So I just totally made this up, right? But if we showed that power every time, it's unnecessary. And it would get very complicated and weird, and it would be very difficult for us to write things cleanly. And so just when we are writing quickly and stuff, we often have abbreviations, or when we speak, we drop the endings of words, in English at least. Similar to that, we drop all these ones because nobody wants to deal with that. Nobody wants to have to try to write out all of these powers explicitly. So, and you ask, does y have the same properties as x? What do you mean? What properties are you asking about? If you're asking about variables in general, yes, no matter what the variables you have, they will follow that property. So, hi, Icy Yogi. Okay, so I do believe I had a redemption to practice my Swedish really quick. So let me get that loaded. Hold on. Oh, there's Duolingo. Oh no, I'm just starting to learn adjectives. Shoot. Those are all new to me. Let me grab my headphones. Okay. All right. Let's practice the Swedish. So I'm gonna pause the music for a second so I can hear stuff. I'm not gonna speak because for some reason, because the microphone's being used by Streamlabs, it breaks Duolingo, so apologies in advance. Oh no, Strophe isn't with us tonight. Goodbye. All right, so I don't really want to practice my adjectives because those are brand new. What should we practice? I guess I should probably, where are my mistakes? Usually I can work on my mistakes. Oh, I don't see those. What should I practice? I guess we'll just go over jobs again. Rebo9487, thank you so much for following. Welcome to Math Monday. Somebody just redeemed practice my Swedish. So give me 1 second and we'll get back to the math in a moment. Oh, how do you do plural of sec? No. There's a lot of R's. I don't remember how to do the plural of secretary. And my notes are all the way over there. No! Hold on. Shoot. Shoot. Let me see my notes. Hold on. How do I do the plural of secretary in Swedish? Oh, I didn't write down one. Well, you know what? We're going to guess then. Ha! I love when my guesses are right. Thank you, Loafbone. Mina Forel. And DRK. This is Duolingo. Yay! What? Oopsies. Oh no, this word. Oh, that's a guess. I don't have fika often yet.
Är hennes föräldrar författare?
Are her parents authors? Yeah. I'm learning my Swedish.
Varför arbetar du som författare?
Oh Jesus, I'm gonna have to listen to that again. Hold on. And Karinger. So I use Duolingo more for vocab practice, and then I have a couple of other resources I'm learning more for grammar and whatnot.
Varför arbetar du som författare?
What?
Varför arbetar du som författare?
Oh. No, I don't think that has an A. It's like that. Kringer, thank you so much for following. So why, I'm not sure if I got all the accents right. Why are you working as an author? Yes, okay. Yeah, so easy. That's not how you spell that. Odd. So I'll say this. Oh shoot, hold on, I gotta listen to it again. But I'll say this is somebody who like has previously spoken, like studied and used to speak French fluently. That it's really tough how similar sometimes Swedish is with French, because it's close enough to mess with my head a little bit. And then my brain like switches over. It's like there's a crossed wire, and my brain switches over to French, and then I'm like, wait, what's going on?
Jag hittar inget arbete. Jag hittar inget arbete. Jag hittar inget arbete.
Ah! I find no work, not I find no worker. Poop.
Vilken karriär?
Oopsies. No, don't show me. Oh, now we know the answer. Oh, there isn't an accent? Oh, that's difficult.
Jag går till läkaren på torsdagar.
What?
Jag går till läkaren på torsdagar.
What?
Jag går till läkaren på torsdagar.
Oh my god, I can't make out any of this. Hold on.
Jag går till läkaren på torsdagar.
I'm going to the doctor on... Oh, I go to the doctor on Thursdays? Tuesdays? Thursdays. Oh, come on.
Personalen arbetar på helgen.
Ray March! Shoot, I gotta like hurry this up. Hold on. The staff work. Oh, that's screwy. On the weekend?
And a C++ library that does it kind of like something like that. And they were like, that was really interesting. That
Hans
inspired me to do something
Henna.
similar. But I also didn't want to like go all the way into like programming language invention town.
Programming language invention town. I like that. Ah, it is with an S. Poop on a butt.
Jag hittar inget
Hi,
arbete.
Ray March. Somebody redeem do Swedish real quick, and then we're back to math. So give me 1 sec, Raiders. Hold on.
Jag hittar inget arbete.
What was it?
Jag hittar inget arbete.
I think it's that. No? Oh, why do I keep doing that?
Läkaren på torsdagar. Jag går till läkaren på torsdagar.
Like, oh. Almost done. I'm sorry, I made so many mistakes.
Jag hittar inget arbete.
Is that it? Okay. Jeez. All right. Woo. All right. We're done. We did it. We did our review. We did the Swedish. All right. Okay, back to math. What even is math? We were doing languages. Ah, all right. Switching a little bit over here. All right. Let's get this all set up back again. I am going to, before we, so now that we have covered all of the wonderfulness that is exponents, let me find, here we go. Here's what we're doing today. So we just finished up with exponents and rules, and now we're gonna go on to talking about monomials and polynomials. I am going to use the restroom really quick, so I'll be right back. But when I come back, we'll dive into monomials and polynomials, so don't go anywhere. If you've got questions in chat or anything, let me know. And also, Ray March, again, thank you for the raid. Sorry it was like randomly during Swedish time. And no, I will not be doing these streams in Swedish, not for years, probably. There we go. All right. So let's get back to math. Let's get back to math. Oh, good night, Remarch. And viewer, there is a wonderful schedule command just for you. And Death Hacker, yes, of course. Obviously, everybody should seriously, I mean, not just when you use the bathroom, but before you make food, after you eat. It's always a good idea after you sneeze, stuff like that. It's a good idea to wash your hands, stay safe, etc., etc. All right, so we've gone over the rules of exponents. So let's start talking now about monomials and polynomials. So let's see here. Monomials and polynomials. All right. Yes, and stay hydrated. Okay. And thank you so much for following, viewer. All right. Sounds like sort of impersonal. I'm just like, random viewer, thank you for following. But, okay. So, monomials and polynomials. These are fancy sounding words for very, very simple things. So first, monomials. Even if you don't know what this is, especially for my native English speakers, mono should kind of, it's a root that you can remember, meaning one or a single of something. So like a monorail, or a monopoly, right? One of the things that really helps when you're learning all of these terms in science or math is learning some of the kind of the roots, and that can often help you kind of remember the fancy names for stuff. Anton Goroditz, thank you so much for following. I mean, you know what? Why am I married? Why am I suddenly a Mrs. now, chat? Something happened, I guess, when I wasn't paying attention. All right. Monomials. So here, married to math and science. There you go. Okay, that's a marriage I can get behind. This is mono here, one or single, because we're gonna talk about terms. And if you remember talking about terms previously, hopefully you all remember what terms are. A monomial is a single term. So that could be anything like a whole number, or it could be 7x, it could be 3y to the 56th, and it could be 72xyz to the 4th. I mean, I'm just making stuff up here, right? But all of these are monomials. They are single terms, okay? And I feel like we're gonna talk about something called degree, and this is where it can be helpful to learn this now. We're not gonna need it immediately. So just, if I've earned some of your trust, please trust me when I say that while this might seem like a weird math thing, I'm not telling you to memorize it, but I'm saying that we have a special word for an attribute of monomials and polynomials, and that's called degree. Okay, and the degree of a monomial is, because I always get this mixed up, so I'm going to make sure in my notes that I'm explaining this correctly, because monomials and polynomials have different definitions of degree, which is annoying. Yes, so the degree of a monomial is you add up all of the exponents of the variables. And I'm going to underline this. So if we're going to go through these, what is the degree of each of them? So what is the degree of the first one? What is a monogamous polynomial? What? Chat, you're silly. You're silly tonight. So much silliness. What is the degree of 32? That's your hint. Enough talking about Daenerys. Do your math. Yes, yes. Cootie Juice and Kosh Fader, absolutely. The degree is 0. And yes, arrhythmia, you got it too. Because guess what? We have no variables. We got no variables, so we're not going to have a degree. Now. And so, viewer, no. Monomials mean, I think what you're referring to is linear. So linear means degree 1 for an equation. Monomial means a single term. In this case, it's a single term. What about the degree for 7x? What would be the degree for 7x? Yes! Matthew Escalin, Azulma. Yes, yes, yes. Yes, arrhythmia. Viewer. Yay, everyone's getting it. Good. All right, what about for 3y to the 56th? This is where me making up random numbers actually becomes kind of funny. Ooh, we're getting some interesting answers here. Yes, viewer, Kenpafu, Scolopos, Squidshire, Matthew Escalin. Yes, 56. So I know we got a smattering of different answers there. But remember that 3 is not a variable. That's a constant. So it's a coefficient here. So we're not going to count that. And then the only thing we have is the power or the exponent of our variable, which is 56. And look, when you ask, can you re-explain it from the start of the page? Absolutely. So, are you talking about re-explaining monomials? Because I will say this, I'm not going to go back to the very start of the stream. But a monomial is a single term, okay? Mono, in this case, kind of smushed with gnome, but mono, single term. And we've learned previously that a term, right, is a whole number. It's a number. It doesn't have to be a whole number. It's a number. It's a variable. It's a coefficient and a variable together. But we have no operations, right? It's a single term. And monomials have a property or an attribute, a trait, a way that we can describe them called degree. And a monomial's degree is different from a polynomial. And trust me, I hate this so very much because most of you who are confused right now are thinking of the polynomial definition of degree, but they are different. I know, what? And to be honest, if we're gonna have a real talk moment for a second, I'm gonna tell you what the degree of a monomial is, but I've literally never used it in my life. A degree of a polynomial, I've used a lot. So take this with a grain of salt. I'm gonna tell you it so that you have the information, but when it comes to what's useful, I feel like as you move forward in math, understanding the degree of a polynomial is something that actually is helpful, in my humble opinion. All right, but the degree of a monomial is the sum of the exponents of all of the variables. And this is where you have to remember, no, why are you, stop it. Okay, well now we're stuck with a little thing reminding us that the red pen is red. So, sorry. But, you know, for 7x, we have to remember that we have that shorthand where we don't write to the first power. And Squidshire, yes. Okay, so no, that is not outside the scope. That is an excellent question. You say, I'm reading that a monomial can only be a product of positive powers. Is there a reason for that would make sense at this stage? So actually off the top of my head, I can't remember if we've gone over negative. I feel like we have. but just in case, a little bit of a reminder that negative exponents, and if we haven't, I'll make sure that I leave time for this before the next Math Monday session, but negative exponents are, guess what? Guess what? More shorthand. So this is a shorthand for division, essentially. So if we have, let's say we've got 4x to the negative 1, and this is times y. Okay? If this is our situation here, this is the same thing as y divided by 4x. Okay? So the reason why this no longer, like, we can't have the negative exponents is because suddenly we have the division. We're dividing our variables. And so that becomes no longer a monomial technically. Yeah, technically. So because you have an operation in there essentially of division. That's at least my understanding of it, but I will I'll look into this more and go into negative exponents next time. Because I don't think I've gone over negative exponents yet. So tiny bit outside the scope, but hopefully that was a little bit of a teaser. Okay. So now that we've gone over monomials and what the degree is, what is the degree of our last monomial here? And Ed Stroyer, we will talk about complex numbers in the future. Yeah, Keyturn, I'll look into it more and make sure that I've got a really good explanation for you all for next time, okay? Yes! Yay! Looks like everyone's on the same page. 6. Good, because we have x to the 1, y to the 1, z to the 4. 4 plus 1 plus 1 is 6. Yes, PK Patricia. Exactly. Okay. But like I said, I can't remember a single time apart from arbitrary math tests when I've needed to think of the definition of monomial degree. Most of the time when we're talking about degree, you're going to be talking about polynomials. And if you want to take a guess here, if we just talked about monomials being a single term, what do you think a polynomial is? There's your hint. No, I would yell at you, but you can go ahead and try. You can go ahead and try, Def Hacker. Multiple terms. Yes, exactly. Specifically, we have the addition of multiple terms. Okay. The sum of monos. Exactly, Scalopos. All right. So, and Matthew Escalin, you ask, what do you call if it's y to the y that is no longer a polynomial? Yeah, that's not a polynomial. It is not. That would be a monomial. So what can somebody who has also probably been here for my PEMDAS rant, tell me, why didn't I put subtraction here? And I know Def Hacker is lying right now. Absolutely. Oh my god. I've met you. You do not look like a troll. You're beautiful. Good lord. Some people are like very unaware of their own beauty. And Def Hacker is 100% one of those people where you're like, you're super smart and gorgeous and what? Seriously? Is it exponential, not monomial? Okay, thank you, Whiskery Ant. See, and this is where like the terms, I will be completely honest with you. This is where the terms are not my forte. And like the distinctions and the mathematical definitions, I review them so that I can tell you them. But there are certain things, obviously, like polynomial that are really useful to know. But sometimes the nitty-gritty distinctions are not always my forte. Okay, and PK Patricia, you are absolutely right. It can be the addition of multiple positive or negative terms. The addition of a negative term is subtraction. So we don't even need to say subtraction. Yes, Squidshire, and you just summarized that perfectly. Thank you. All right, so there's kind of like a type of polynomial where we have two terms, and that's called a binomial. You also might hear, oh yes, wait for it, trinomial. And at this point, I think you all should be old hats at figuring out what these mean. Okay, but just like with monomial, polynomials have an attribute, a trait of degree as well. And now this, I think, will be the one that is most familiar to everyone because it's the one that's actually useful. So, who wants to tell me what polynomial degree is? How do we define the degree of a polynomial? Does anyone know? It's cool if you don't. Oh, Deaf Hacker. Oh my gosh, my community is just going to shower you with love. Go forth, community. And yes, Deaf Hacker. It's the certificate you get when you finally understand polynomials. Squidshire. Ha ha. And yes, Har457, you are absolutely right. It is the highest degree of the terms. Exactly. So, oops, I know my head's in the way. I apologize. Hold on. Move that up for all of you all. Okay. So, just see if I need to do anything else. Looking over my notes. Give me one sec. Yes, all of you tell Deaf Hacker how beautiful she is. Yes, I already covered that. Thank you. Past me. Okay. So when we are simplifying polynomials, we'll do this first. Simplifying. Uh-oh. The whiteboard is lagging. I feel like that's always my cue of like, maybe Math Monday is too long. I also feel like, I don't know if anyone else has this, but it just surprises me that people are willing to, I don't know, watch like a 2-hour video on YouTube that's a VOD. So I've been trying to keep them shorter in the hopes that more people will find them interesting on YouTube, but we'll see. All right. So let's make up an example. Oh gosh. Let's make sure I'm not screwing all this up. Give me a sec. Pre-roll ads are on Twitch. I tried. I'm sorry, friends. I rolled an ad when I went to use the bathroom because I was hoping that if I do that, it would get rid of like the pre-roll ads for folks trying to find the stream or like jumping in. But apparently Twitch hates me and wants to roll the ads anyway. So I'm sorry, friends. All right. So let's talk about how we might simplify this. I see Yogi, that would be wonderful because usually the only comments I get for the most part are like weird spam bots. All right. So when we simplify polynomials, and so yeah, so not lab, right? Here's the thing. And this is why I don't like monomial degree, is that like, to my understanding, but please, those of you who are better with like the nitty-gritties of the terminology, correct me. To my knowledge, that would be degree 1, because it's about the degree of the variables. Yeah, right? That's not second degree polynomial. I think that's still a first degree one. And that's why I'll look into that though, just to make sure that I'm not like filling all of you all with complete and utter. It is degree 2. I hate degree. Because it's the degree then of the monomials. It's the maximum degree of the monomials. Whatever, math. All right. It is 2? Okay. No, I believe you. I believe people who know their terms way better, their terminology way better than me. So thank you, Whiskery Ant. Math is a cruel temptress, but we all love math. All right, so one of the tricks that I like to use when I am simplifying polynomials, okay? And yes, all right, I'm sure there are plenty of you in chat who are like, I'm the math expert of the universe. I can do this all in my head. I will say this. I can do a lot of it in my head too, but guess where the mistakes happen? The mistakes happen when I do it in my head. And so if you're gonna make a mistake, it's probably gonna be if you're trying to skip steps. So especially in the beginning, I'm gonna show every single step. One of the ways that I like to show people how to simplify polynomials is, it's a little bit silly, but go from, I don't know, let's go from the greatest degree and let's work our way down. So here we have x cubed, right? X to the 3rd power, x to the 3. And here we have one. So the first thing I do is I underline both of them. And then I look, do I have any other x cubes? I don't, okay? So then I write that out. Boom, there we go. And cross it out because we're done with it. We don't care about it anymore. All right, now I'm looking for my next degree. And here, whoop, I see a squared. I see to the 2nd power. So I'm gonna underline that. Do I see it anywhere else? I don't. So we're gonna list that, cross it out because we're done. Now we are at x to the 1, or just x, right? And we've got one here. Do we have it anywhere else? We do not. So then I copy that, cross it out, running out of colors. Shoot. Blue. And then last, I look at my constants and copy those out. So everything's crossed out. Have I missed anything? I haven't. So now everything is in the right order to simplify. And so 2x cubed plus x cubed, don't worry. Are the bases the same? They are. Then you follow the normal sort of rules that we've been using so far, which is just you add your coefficients, right? We have 2 x cubes and we have 1 x cube. So we've got 2 bananas and 1 banana. We put them together, we get 3 bananas, right? Doesn't matter if it's x cubed or a banana, the rule applies. So we have this. Now we don't have any other x squared terms in here, so we can just keep that the same. And same with our x term. And lastly, we have our negative 15 plus 10. We all should be experts now at dealing with our negative numbers, and we know that this simplifies to negative 5. And so the multicolored pens aren't a requirement, but I will say this, is that especially when I've had students with dyscalculia or dyslexia, I give them multicolored highlighters and multicolored pens that match. And it's been a way, or even kids with ADHD, it's been a way of having kind of a stimulation or another way to encode the information that really helps them. And if, like, I can pass on a life hack, especially for a lot of the educators in chat, if you are dealing with students, well, one, you probably have students with learning disabilities and you don't know it, because a lot of learning disabilities are undiagnosed. But 2, if you ever are trying to make your syllabus or your teaching style more accessible, the fastest and easiest way, apart from the things that you know, like captions and transcripts, is to present information in multiple ways. So, and also, Just Neff, thank you so much for following. But if you look at what we've done here, I haven't just encoded the information for you in writing, like based on the shapes of the letters and the numbers that I've used. I've used order. So we've grouped the x3s together, the x cubed together. We've grouped, our constants together. And I've used color. So that means that you all are getting 3 different modalities or methods or modes of information presented to you. And even if you feel like you are 100% neurotypical, you have no learning disabilities whatsoever, guess what? It still works for your brain better. The human brain, the more ways that you present information, the easier and better it is to learn. It's a great philosophy to follow when you're doing data visualizations as well. So you don't just encode things with color, for example. On a plot, you encode them with shape and with thickness and things like that as well, and labels. But it's a great thing to also pick up when you're teaching, or if you yourself start to struggle with math, or honestly, really any subject. Think about ways that you can break down the information and present it to yourself through multiple modalities. It's a very good back of the hand kind of way to try and make your content more accessible. And Blue Squid, I've also found when I teach, and a lot of you who've been here for previous Math Mondays have seen this, when I'm teaching simplifying equations, a lot of times I'll use the 2 colors as well, where one color is the things that haven't changed, and the second color is the step that we've changed, so that it's very easy as you're going through to just quickly see what is the step that, this person did from line to line. And actually, when I was in graduate school, that's how I wrote my math and my physics homework. Is I used a blue and a black pen or a red and a black pen, and the one color, the blue or the red or whatever color I was using, was for whatever change I was making. And 1, I find it easier to grade, and 2, it was easier for me going back and checking my work to see kind of maybe where I've made mistakes. But there you go. And Iopta, don't you run away. There's no math dislike here. Well, people who hate math are also welcome. I will change your mind. I will convert you. I think I have a Tennessee. Tennessee? Ten? Why are you... Somebody opened my office door and has snuck in. Hi, Ten. He wants to sing. He will sing for us later, I promise. Okay, and you're welcome, Rebo. I'm so glad that you find it useful. All right, so I think hopefully this makes sense. Simplifying polynomials. Are there any questions about simplifying polynomials before we move on? There's 1 or 2 other things I wanted to cover tonight before we wrap up. Let's see. I don't think we're gonna have time to get to that. Yeah, I'll do that. All right. I'm gonna just write another example, but if you have a question, feel free to pause everything, interrupt. It's not a problem. And let's see. How do I want to do this? All right, no questions. Wait, Def Hacker, send the link to Loafbone, and if you're comfortable, and he can post it in chat. Wait, we took pictures together at the Icarus Interstellar at Starship, the Starship Congress conference. right? We totally had to take, because also there was that really adorable Australian Shepherd puppy that I think both you and me spent a little too much time hanging out with the puppy during some of the talks. All right. And DRK, I try to keep things about 2 hours. So looks like I've been streaming about an hour and 40 minutes. So I'm aiming to wrap things up probably around 9:30. I've gone for longer before, but I found that I start to get really fatigued if I stream for too much longer. And then also, I think it's a lot of math to learn in one night. So, all right, this is probably the last thing we'll do, and then I'll take questions, and then we'll do a Tennessee song. But nevertheless, first of all, little bonus question for all of you. What is the property that we're going to use here to simplify this polynomial? Well, I know that you know the right answer, Def Hacker. You're literally a mathematician. Duh. But what is the name of the property that we're going to use here? Har457, you ask, is it associativity? So, not yet. And yes, that math teacher and Kosh Fader, distributive property. So that means we're going to distribute, right? We're going to pass out, just like you're passing out a sheet of paper. We're going to distribute this negative 3x. So let's write out what that looks like. So remember, our operation here is multiplication. So literally, you just copy it. That's all you got to do. I promise. It's not scary at all. It's gonna run into my head. It's small. So look, we attached a negative 3, because remember, just in our math shorthand, when we have no operation in between a term and the parenthesis, that means that there's a hidden multiplication right there. Right? We just drop it because, who wants to write all of that out all the time? So we're just taking this and we're literally copying it. Should be like the copying property, right? We're just copying it and multiplying it by each of the terms here. So let's simplify this now. So first, we're going to take it one term at a time, okay? So first, we have negative 3x times 2x squared, okay? Put Loafbone in the timeout corner. What has Loafbone done? He hasn't done anything wrong. Okay, so first we handle our constants, our coefficients, right? Negative 3 times 2. Negative 3 times 2, we know that, negative 6. And then we have x, and right, we know he did, I mean, I agree with him. So that's the best poll, and he's 100% right. So this should be called the removing the parentheses property. Exactly, Har. I vote we just rename everything in math. Okay, so we've got negative 6. Remember, this is x to the 1, x to the 2. What do? We add 1 plus 2 because we're doing x times x times x. 3 x's, x to the 3rd. All right, next. Now we have a negative 3 times a negative 5. If you're interested in learning why a negative times a negative is a positive and it's not just a rule you should memorize, I covered that in one of the first Math Monday videos. So I definitely suggest taking a look at that so that you're not just memorizing things, right? But negative 3 times a negative 5, we have positive 15, and we have an x and an x, and we're multiplying that. We have 2 x's, x squared. Oopsies. And also, I can math. And oh, and I added a y. Hold on. Hold, please. Minus 3x. This should be... Yes. Okay. No, we're fine. Goodness. I'm a little sleepy. Sorry. Bear with me, everyone. All right. So, last... All right. We have a -3 and a 6. And an x. And that is how you simplify multiplying a polynomial times a monomial. Now, I'm going to give you a little preview of next time before we wrap up. And so we've done this kind of in one direction, right? We know how to go from multiplying this monomial times this polynomial in parentheses all the way down to this trinomial here, right? How do we go the other direction? So by that I mean, if we start out with is it minus? Yeah. If we start out with this, can we extract things that each term has in common? And the answer is yes. So this is where I know this is something that a lot of people struggle with. So we're going to take it one step at a time, and this is just a preview. So we'll work on this more next time. This is a process called factoring. Okay? And this is what we'll do next time, but I'll give you a little bit of a preview. So first, I like to, at the very beginning, look at all of my variables. Whew, there we go. English. And I see what they have in common, right? And so here, well, x cubed, I could think about that like x squared times x. X squared is just x times x, and x is just x. So the thing that they all have in common is an x. So if I pull that out, if I factor that out, if I divide by that, so x to the cubed divided by x, we get x squared. X squared divided by x, right? We're taking away an x. We just get x. And then 18x divided by x, we just get 18. Now that we've handled our variables, we need to look at our coefficients. And what do 6, 15, and 18 all have in common? 3. So we can also divide by a 3. So let's pull out a 3 now. So -6 divided by 3 gives us -2. Stick with my colors. -2. And then if we divide 15 by 3, we get 5. And if we divide 18 by 3, we get 6. And so this is a process called factoring. And you might wonder, why would we want to kind of undo all of the simplification work we did last time? But I will teach you why this is the case next time. So hopefully that is enough of a teaser to get you to come back. But Lofum, will you put up a poll while I'm answering questions? Can you put up a poll on what Tennessee should sing for folks? And let's chat for a little bit. And yes, I know, Blue Squid, that's a very, very common question, is why are we undoing all of the work that we did trying to simplify this? And I mean, obviously I'll show you next time, so I got to give you a bit of a teaser. But I'll say that one of the things that we haven't talked about with polynomials of a factor greater than 1, right? So nonlinear polynomials, is how do we solve them? We know how to solve linear equations. We've got that. If we've got more than 1, we're good, right? But if I have like an x squared plus 5x minus 6 kind of situation, if that equals 11, I don't know, I'm making math up right now. How might we go about solving that? And one of the tools in our toolbox for solving polynomials is going to be factoring. So sometimes it's actually better to have something in a less simple form. It's easier to solve. So don't worry if that, you want to die when I say that. We will go over it next time. It will become less scary. Just think about everything that's been scary so far when I introduce it, and then by the end, everyone's like, oh yeah, I know this already. Snooze. So don't worry. It will become old hat. And let's see. Factoring is not so much an art, I would say, but it is a skill. And the more that you do it, the more of an intuition you get about where to start. So, set it up. Unfortunately, I'm not sure whether the 2 plus 2 that you've listed there belongs in the denominator or in the numerator. So I would need more information first. And the Not Lab, thank you so much for 5 gift subs and for English and for supporting Math Monday. Ed Stroyer, Katemfor, W. Dorset, Gigasloth, and Something VR. Now you all have wonderful emotes of my dogs and also me. So congratulations, you're now subbed. And that means that if you tune in for one of the productivity streams, coming soon, by the way, probably tomorrow, if I set up the lights in time, that means you get free control of my programmable LEDs if you have a sub. But thank you, Not Lab, you're wonderful. And as always, all of the proceeds for this month, and probably, depending on how many streams I'm able to do next month, all are helping me afford the Moving My Dogs and Furniture to Sweden fund. So, thank you. It means a whole lot that, you all are so supportive and encouraging with the content I make. Can I put the LEDs in my hair? Sure. I think so. I'm not sure. I think that the problem is that I did it on my headphones previously, but I think it messes with the green screen is the only problem. Well, Zed it up, I would say that is a syntactical ambiguity, and that's why the internet was split on it. AKA, the way it's written isn't straightforward. And so if the way it's written could be misleading, or it's not, it's not explicit, then that is where the disagreement is coming from. And let's see here. Okay, so the poll was split. The heck am I supposed to do with this, you all? It was okay. So Lovebone is making a new poll. Thank you, Lovebone. I'm gonna go get the diva himself. Do not go anywhere. You will break his little fluffy, gorgeous dog heart if you all run away just because it's not math anymore and it's Tennessee singing. He really wants to sing for you. It's the best part of his evening. You should see how excited he gets. Oh wait, you're about to. So I'm gonna go get him. I will be right back. Pick a song that you would like Ten to sing for you. All right. I'm going to use my co-working stream so that I can have the Tennessee camera already all prepped for you. Let's see. I don't even think you don't need the me cam. All right. Okie doke. Boat in the poll. Boat. Boatosaurus. Let's see, what's this poll? How's it doing? It's still tied. You absolute little turds. Oh, I know. Everybody does want you to sing, Tam. You're gonna come over here. Oh. We have another visitor. Hold on. Hold, please. Hold your snoots. Let's see if I can get them both in camera. Hold on. Okay. And Tennessee, you're gonna come over here. Come on, Patch. You're gonna come right here. Stay. Oh my god, you don't need to roll on your back all the time, Ten. Oh my god, Tennessee. People want to see you sing. Oh my Christ. Now he's upside down. Hi, you're perfect. All right. Let's see, I can probably... Oh my gosh. I'm trying for you, chat. Hold on. Okay. It'll stop swinging in just a second. Hold on. Okay. All right, TNG has won. Give me 1 second here. Volume warning for those of you who are new. Okay, Star Trek TNG. Let's go, boys. It's not time to sing yet. Is there music? There isn't music yet. All right, volume warning. I'm going to turn down the mic, but here you go. Tennessee, it's not time yet. Aren't they perfect? Aren't they 100,000,000% perfect? Ah, I love my dogs. I know, we need a collaboration album, don't we? I'm telling you, it's gotta happen. Though Hubble will only sing under one of two circumstances. If Tennessee is singing, or if there is a fire engine. All right. Yes! Okay, I know exactly who we're rating tonight. So, please follow, etc. I will probably have a productivity stream tomorrow. If not, there will be D&D on Wednesday, Game Dev on Thursday, and a Science Sunday stream on Sunday. But please, super cool stream that I'm a huge fan of, Diatome's Attack. He has a, I'm not joking, scanning electron microscope and streams it. And it's super cool and lots of fun. So please, please, please give a follow, give a shout out, a sub, a cheer, bit, whatever Twitch does. Pass forward all of the love. It's one of my favorite streams on Twitch. And I will see you all next time. Thanks for hanging out with Math Monday.